Okay, simple events and compound events. If I'm going to flip a coin, flipping a coin is one experiment. So the coin will land on heads or it's going to land on tails, right? Since there is only one experiment, this is a simple event. So what if I'm going to spin a spinner and roll a number cube? Okay. How many experiments are there? There are two. There's two things going on. So a compound event is an event with two or more experiments happening. So to tell if it's compound or simple, ask yourself, do you have to do the experiment more than once? If you do, then it is a compound event. Do you have to do two or more experiments? If the answer is yes, you have a compound event. So let's look at this first one. Rolling a six-sided dice twice. The fact that you're doing it twice makes it a compound event. Okay, picking a marble out of a bag with 15 marbles. You're only doing it once, so it is a simple event. Spinning an 8-section spinner once. Yes, it has 8 sections, but you're only spinning it one time, so it's a simple event. Flipping a coin and rolling a 12-sided cube. That is a compound event. There's two things happening. Now we're going to talk about sample space. Sample space is the set of all the possible outcomes in an experiment. I can show these with lists, I can show it with tables, and I can show it with tree diagrams. So let's talk about list. You're going to use like braces or brackets to record all the possible outcomes using a list. So if I have a spinner, Jenny's going to spin the spinner shown below. Represent the sample space of spinning the spinner using a list. So I'm going to make this bracket, and what can she spin? She can spin a W, an X, a Y, and a Z. So that is her sample space. That's all the possible outcomes that she can get in that experiment. Now, what about, there's also a table. So if I've got a spinner with ABC, and I'm also going to have a spinner of 1, 2, 3, 4, this is a compound event. So what I can do is I'm actually going to label right here. I'm going to label 1, 2, 3, 4. And then right here, I am going to label A, B, C. So I know with the first one, I can spin an A. And I'm going to write that for all of these. And then when I spin an A, I can also spin a 1 with that, a 2 with that, a 3 with that, and a 4 with that. Then I could, on the first one, spin a B. And after I spin that B, I can either spin a 1, a 2, a 3, or a 4. I could also, on the first one, spin a C. And then after I spin the C on the other spinner, I can spin a 1, a 2, a 3, or a 4. So those are the different combinations I can make. Now, one of the big ones that you're going to see is a tree diagram. Okay, a tree diagram kind of branches out. So if we look at this, it says represent the sample space of flipping a coin twice using a tree diagram. And then we'll list it. So knowing that we're going to do it twice, the first coin, this right here is going to represent my first flip. Okay, so I can get a heads or I can get tails. Then I'm going to flip the coin again. And when I flip it the second time, I have two options, heads or tails. Heads or tails. So my possible outcomes are these right here. There's actually 4 possible outcomes because I can get heads with heads, heads and tails, tails with heads, tails with tails. So these right here are my actual possible outcomes. That's how many there are. There's 4 possible outcomes. Now I'm going to list them. So to list them, I'm going to use those brackets, and I'm just going to use H and T. So I could get heads and then heads, heads and then tails, tails and heads, and tails and tails. So there is my list. Okay, let's do a little bit more practice. Okay, if you're asked to find the different combinations, we can create a tree diagram. A tree diagram may be created vertically or horizontally, and the number of possible outcomes in a probability experiment is called your sample space. Okay, so example 1. At Marble Slab, okay, that's an ice cream place. It used to be my sister's favorite. You can order vanilla, chocolate, or strawberry ice cream in a cup, a sugar cone, or a waffle cone. So I want to list all the different combinations you can order. So we're going to create a tree diagram vertically. So I can get vanilla ice cream. And what are the choices? Well, now I got to choose my type of cup or cone. So I can get a cup. I can get a sugar cone. Or I can get a waffle cone. Okay, what if I got a chocolate ice cream? I can still get a cup, a sugar cone, or a waffle cone. I'm abbreviating now. What about a strawberry? If I get strawberry ice cream, I still have the choices of cup, sugar cone, or waffle cone. How many different choices or combinations, how many different combinations can I make? I can make 9 different combinations. So if I make a list, an organized list, I can get vanilla with a cup, vanilla with a sugar cone, or vanilla with a waffle cone. I can get chocolate with a cup, chocolate with a sugar cone, and chocolate with a waffle cone. Or I can get strawberry in a cup, strawberry in a sugar cone, or strawberry in a waffle cone. Now, could I do a tree diagram differently? Yes, I can do it. If this one is done vertically, I could do it horizontally, or I could even start from the other direction, or start from like the other thing, meaning I could start with having cup, sugar cone, and waffle cone, and then from there having chocolate, vanilla, strawberry. Chocolate, vanilla, strawberry. No matter what, I'm still going to have the same, have the same thing, same number of different outcomes I can have. Okay, now let's say that I roll a dice and flip a coin, list all the different outcomes. So I can roll the dice and I can get a 1, 2, 3, 4, 5, or 6. After I do that, I'm going to flip a coin. So after I've rolled the dice, I can flip the coin, and if I roll a 1, I'm now going to flip a coin and I can get heads or tails. If I roll a 2, when I flip the coin, I can get heads or tails, heads or tails, and so forth. How many different combinations are there? There's actually 12 different combinations, because I can roll a 1 and get a heads, roll a 1 and get tails, roll a 2 and get a heads, roll a 2 and get a tails, and so forth. Now let's look if example number 3, you flip 3 coins, list all the possible outcomes, and draw a tree diagram to help you. So we're going to start by drawing a tree diagram. Okay, with the first flip, I'm going to flip my first coin, and I can get a heads or I can get a tails. Now I'm going to flip it again. If I get a heads, I'm going to flip my second coin, and on my second coin I can get heads or tails. Same thing with if I first coin's tails, my second coin I can get a heads or a tails. But then I'm going to flip that third coin. So when I do that, I can now go from there and I can get heads or tails on that third coin. So no matter where I am on that second flip, on that third flip, I can get heads or tails. So to recap, I was able to get heads, heads, and then heads. Or I could get heads on the first flip, heads on the second, and then tails on the third. Or heads, tails, heads, heads, tails, tails, and so forth. So I'm going to put that in a list. So I can do heads, 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 or heads, heads, tails, heads, tail, heads, heads, tails, tails. Or I could get tails on the first one, and that would be tails, heads, heads, tails, heads, tails. Or I could get tails, tails, heads, or tails, tails, tails. So there were 8 possible combinations. I hope that helps.